Hello everyone. In this video, we will be talking about bitwise operators. These operators can only be used on integers and they will only return integers. How they work is that they basically convert the integers into binary and then perform the calculations on the individual bits in the binary. So for all of the examples, I'm going to run the code and show you the result of the calculation. Then I'm going to switch to a screen that has a spreadsheet table as well as a website that shows binary to decimal number conversions to show you how it's calculating that. So for the first one, we have bitwise AND, which is denoted by a single ampersand. So 178 ampersand 219. When we calculate this, we get 146. So here's how the ampersand bitwise operator works. Basically, we've got the two integers here in their binary form. For each bit and each column, if both bits are 1, it will return a 1. If one bit is 0, or if both bits are 0, then it will return a 0. So for this column, we have a 0 because we got a 0 up here. For this column, we've got two 1s, so this will be a 1. Another 0, another 0, a 1, a 0, a 0, and a 1. So that's the resulting binary we get from this calculation, which if I put in here, results in 146. Bitwise OR, which is denoted by a single pipe character, which is on the key with the backslash character. And if I run this, we get 251. So how Bitwise OR works is basically for each column, if at least one bit is 1, then it will return a 1. So for the first one, we have a 0 and a 1, so we get a 1 because this one down here is a 1. We've got two 1s, so that'll be a 1. Two 0s, that's a 0. Another 1, 1, 1, 1, 1. So if we put that in here, and we get 251 just like in the code. Bitwise XOR, or exclusive OR, is denoted by the little caret symbol, which you would get if you held Shift and pressed the 6 key. And if we execute the code, we get 105. XOR is like OR, except that there can only be one bit in the column. So if there are two 0s, it results in a 0. And if there are two 1s, it will result in a 0. So we got only one 1 here, so that will be a 1. There are two 1s, so that'll be a 0. Two 0s, so a 0. Another 1, a 0, a 1, a 1, and a 0. And we get 105, just like we did in the code. Next up is Bitwise 2's complement. What it does is it calculates the opposite of the number. So if the number is positive, it will calculate its negative. And if it's negative, it will calculate its positive. It takes a single number and it's denoted by a tilde. Now, one thing I have noticed when putting together this exercise, the calculation is off by 1. So the 2's complement for 99 should be negative 99. But what I get is negative 100. I don't know why. Because if I run this calculation on any calculator out there on the internet, I would get negative 99 like I'm supposed to. And I will show you why it should be negative 99. So the way 2's complement works is that you invert each bit and then you add 1 into the resulting value. So I'll go ahead and invert these. So that should be 0, 0, 1, 1, 1, 0, 0, 1. And then we add the 1. And so that's our result. Now, one quick thing to note, when a binary is looked at from a 2's complement perspective, this last bit here is actually used to denote whether or not a number is negative or positive. So if it's 1, then it's considered a negative. If it's 0, it's considered a positive. So if I enter this number in here, as you can see, we get negative 99 like we're supposed to. The way Python's been calculating it, it seems like it's not adding the 1, because if I change this 1 to a 0, then we get -100. So I'm not quite sure what that's about. I don't often work with Bitwise operators, so maybe there's something I don't know about. I just know how they're supposed to work and how they do the calculations on paper. So yeah, I'm not quite sure why Python is spitting out -100, but the answer is technically -99. Next is the Bitwise left shift operator. What left shift does is it shifts the bits in an integer over a certain number of times to the left. In this case, we're going to take the bits in the integer 25 and shift them to the left twice. So when I calculate this, we'll get 100. So here we have the binary for 25, and we're going to left shift it twice to get 100. So the first two bits are going to be 0, because we're shifting in this direction, and since there are no bits on the left of this 1, it's just going to be 0. Then we're going to put the 1 here, followed by the 2 zeros, then the 2 1s, and then finally a 0. And if we put this in here to check the work, we get 100. And finally, we have Bitwise right shift. Right shift is like left shift, except we shift it to the right instead of the left. So here we have 77 right shift by 2, which when we run it, we get 19. So here's the binary for 77. So these 2 bits are going to be gone because they get shifted off. So the first bit in our new number is going to be starting here. So 1, 1, whoops, 0, 0, 1, 0. And then because we've got 2 new bits here because we've shifted here, these are just going to be filled in with zeros. And we've got this number. Now to check our work, and we get 19. And that's it for Bitwise operators. If you enjoyed this video and found it helpful, then please leave a like and be sure to leave a comment below to let me know what you think. If you want to see more, head on over to Wayfair Coding Academy channel to check out my other content, and while you're there, subscribe to the channel to stay up to date on new stuff as it comes out. Thanks for watching, and I'll see you guys next time.